Today, we'll be demonstrating modern privileged identity management with Signal, which enables protection of your critical systems in real time. In this demo, I'm going to show you how Signal secures cloud infrastructure by protecting against damage from excessive standing access granted by identity providers like Okta. With more than 80% of organizations having suffered an identity-related breach in the last 12 months, it's clear that existing security controls are not adequately protecting enterprises from breaches, and identities are the prime target for threat actors. Today, many organizations use single sign-on as a secure entry portal into applications and services. While identity providers are great at verifying a user's identity, without data from a company's range of SaaS applications, such as CRM and HRIS services, they lack the capability to make authorization decisions based on dynamic business justification. When these identity providers are then used to authenticate high-value, high-risk sign-in events, users are often permitted to access sensitive data with limited restrictions. Once attackers have bypassed SSO defenses, they can proceed to infiltrate a number of critical systems, gain access to sensitive resources such as databases, virtual machines, and more. Take a fictitious company called Wholesale Chips, for instance. Wholesale Chips uses Okta, an identity provider, to federate their employees' access to GCP, where they store sensitive data, virtual machines, and more. Without Signal, users can access Google Cloud Platform, or GCP, through Okta as long as their long-standing attributes comply with simple policies. However, if a user without proper business justification accesses GCP, such data and resources are put at serious risk. For instance, in 2020, a Google Cloud data breach impacted over 201 million personal records, exposing over 800 gigabytes in sensitive information, such as addresses, mortgage and tax records, and more. Wholesale Chips is a prime example of an organization that can enhance their authorization through Signal. With Signal, they're able to grant dynamic access to GCP by validating that access using data from systems of record like Okta and ServiceNow to determine if the right user is requesting access at the right time, then immediately revoking access when context changes, achieving zero standing privilege. Let's go back to examine the scenario where Wholesale Chips does not have Signal. Wholesale Chips has designated a role-based access permission in Okta, specifying that all engineers are granted full admin access to GCP for use in emergency situations. Alex, an employee in the engineering team, is therefore allowed to federate to GCP using Okta at any time. Without Signal, Alex is given access to the entire GCP environment, allowing him to access and manipulate sensitive information that may be beyond what he needs to solve the problem. Using Okta's Apps dashboard, which has integrated sign-on to GCP through Okta's single sign-on service, Alex will now attempt to access GCP. As you'll be able to see here, Okta signs him into the GCP management console, giving Alex unfettered access to other data and virtual machines, as well as users, roles, policies, and permissions. But should Alex have this heightened level of access in GCP, which allows him to create new GCP users or use sensitive data stored in the cloud? We'd like to introduce you to Signal, which helps organizations answer that question. Here is the Signal dashboard for Wholesale Chips, which integrates with systems of record to unify critical business context that is applied to policies to inform real-time access. Let's delve deeper into the systems of record that are synchronizing data into Signal to support policy decisions. Similar to numerous organizations, Wholesale Chips makes extensive use of third-party SaaS applications to manage their engineering team, customer service, employee directory, and human resources. They've integrated their applications as systems of record into Signal, syncing business context from Entra ID, Okta, and ServiceNow, which is their IT service management platform. Now, let's see how those systems of record can help you protect your critical systems in Signal, which we call protected systems. Signal can enable conditional access for your cloud infrastructure, code pipelines, and customer data. In this demo, we'll focus on the GCP use case. To protect GCP, Signal has integrated with Okta to add authorization layers to Okta sign-in flows for access to GCP. We do that through transforms, which leverage inline hooks from Okta to allow Signal to be involved in the decision-making process for the roles and permissions granted to a user in the process of federation to GCP. Now, with our systems of record and protected systems in place, let's look at how we can configure policies in Signal to restrict access to GCP to users with significant business justification. Coming into the Policies tab here attached to GCP, we can see that engineering users can access production assets if they have an active emergency case assigned. Taking a closer look at this policy and examining what this condition means, we can see that access to production assets is restricted to users who have an active emergency approved ServiceNow change assigned to them. With this new policy defined, Alex will need to be working on a task or incident in ServiceNow that gives him business justification if he wants to access GCP production assets. Let's now give signing in to GCP through Okta another go. Since Alex has not yet been assigned the relevant ServiceNow change yet, we'd expect that he is denied access to resources in GCP. To see what's going on here, if we go into the resources that Alex has in GCP, we'll see no organizations here. This means that while Alex was allowed to come into the GCP management console here, he does not actually have any permissions or roles assigned to him, and he can't access any of the project information. For instance, if we look up IAM, we'll see that Alex does not have access to this information since he can't select any of the projects. Thus, Signal has successfully configured GCP permissions to deny access for a user who did not have a business justification. With that, let's come over to ServiceNow here and assign Alex the change that he needs to access GCP. We can see that this change here is active and that it's of type emergency and that it's a high priority, high risk item. We also note that the configuration item here is set to security admin. Let's go ahead and assign Alex to this case, and let's also go ahead and approve it for Alex as an administrator. Alex now meets the criteria that we defined in our Signal policy for emergency access to GCP. Jumping back over to the Okta's Apps dashboard, we can expect that Alex is now able to access GCP as he has the business justification to do so. Going into the resources that Alex has access to, we now see specific resources populated by the security admin scope that we had specified in ServiceNow, meaning that Signal has given Alex just the right level of access needed to complete his task, as determined by ServiceNow. Remember that before we had assigned him that ServiceNow change, all that this showed was no organization, meaning that Alex did not have access to specific projects and resources like this example. With this in mind, we'll be able to look up specific resources like cloud storage to see that Alex has access to such resources. Now, even though Alex was compliant with policy when he signed into GCP here, according to our Signal policies, things could change. By default, GCP sessions are 16 hours long, which is short compared to many systems that maintain sessions for days or even weeks without checking if access is still valid. But what happens if Alex completes his work or the emergency incident is closed before that time is up? In many situations, Alex would retain access to GCP even when he no longer has the business justification to do so. But with Signal, we can continuously listen for those changes around business context and determine when Alex's access should be modified. To demonstrate this, let's say that we no longer need Alex to work on this emergency incident. So we come in and cancel the change in ServiceNow. Let's say no longer needed. Since we had defined that an active emergency change is needed to grant a user's access to GCP, Alex is now no longer compliant with our policy. Signal will notice this and revoke Alex's access to GCP. If we refresh here, we'll see that Alex's access is revoked in real time. Signal can also notify security operations teams when actions like session revocation occur. Going into Slack here, we can see that Signal has also sent a notification about Alex's GCP session being revoked. Thus, Signal has continuously granted and revoked Alex's access to GCP, eliminating standing access. We can take a quick look at how this works under the hood inside of Signal. In our Continuous Access and Evaluation Hub, or KPUB, we can see here that some actions have fired. Specifically for Alex, the revoke GCP session and notify trigger was set off, which we've defined here as when the closure of emergency access requests occur, just as we did when we canceled the ServiceNow change. Just as we saw with Alex, this then resulted in two actions: the Slack notification being sent out for access being removed and the GCP session revoke. Thus, leveraging Cape protocols, Signal can, in real time, eliminate user permissions from live sessions or future sessions of a user in response to a detected identity threat. Since Signal synchronizes access management across protected systems, Signal makes auditing access easy with information from all applications in a centralized platform. For debugging or auditing support, we can also view a log in the policy lens to see why a specific access decision was made in regards to the policy snippets involved. Going back into the logs into the KPub section, we also see the actions logged here when in-session access for Alex's GCP session was revoked after we canceled the ServiceNow change. As you've seen through this demo, Signal helps organizations eliminate standing access by granting dynamic access based on contextual business needs and then revokes that access when context changes. Today, we demoed a specific example of Signal's cloud infrastructure use case with Okta and GCP integrations. To learn more about Signal and other use cases like protecting code or live user sessions through context-based, CAPE-informed policies, visit signal.ai.